All right. Thank you all for being here today. Thanks for listening in virtually as well. We're going to be talking today through the issue of accelerating sustainability with the digital twins. And we have a really great group of panelists here with us today. We also have Karthik joining us virtually. And so since we're dealing with some technical difficulties, especially with acoustics, I'm going to start off. Are we good? Okay. I'm going to start off by asking Karthik to give a little intro and a bit of an opening statement, and then we'll start our conversation with the panelists that are live here with us today.
I'm Karthik, and I'm a machine learning scientist here at NVIDIA, and it's my great pleasure to be part of the panel. I lead various machine learning projects for the Earth-2 initiative, which is a large NVIDIA project recently launched by our CEO Jensen to build digital twins of the Earth for climate change mitigation and adaptation. Thank you.
Awesome, thank you. So let's start with the panelists here. Can everyone go across and give your name, a little bit of what you do, your background in relationship to the concept of digital twins?
Thanks, Rachel, and thanks, Todd, for putting together this Earth Summit. It's a cool event. My name is Nikhil Deshmukh. I'm a senior data scientist at Turntide Technologies. My background is actually, I started in neuroscience, and I left neuroscience to become a data scientist and do AI and machine learning. I worked on sensory systems, like the retina, and so I've been able to translate that to working on IoT and sensors in the real world, and how those interact with software systems to add value. And Turntide is an electric motor company. They build a switched reluctance motor. So it's a more efficient electric motor design, coupled with software, makes a pretty, I would say, optimized joint solution of hardware and software for buildings, agriculture, and for transport. And I work on the building side of things, working on algorithms for building energy management, and specifically for HVAC applications. So how to optimize rooftop unit HVACs for this new motor system.
So you guys know me already. I was on the previous panel, so I'm kind of at the intersection of space and digital twins because we're building, a digital twin platform for spacecraft and constellations. So yeah, now we'll get more into the software and the digital twin side of it.
Sure. Definitely thanks to AI LA and Todd for hosting us. It's fun to be here. My name is Chris Andrews. Currently, I'm an exec at a small startup in the synthetic data space, creating artificial data to train AI, and I can come back to that in a sec. My background, I started off in optical engineering. Which led to me working at a laser fusion facility years ago, actually. I've been in ecology, evolutionary biology was my master's, but I got interested in geospatial technology and programming, and that led to what most of my career has been, bringing together enterprise systems to solve real-world problems. And I'd actually argue that many of the enterprise systems I worked on back in the late 90s were early versions of digital twins. I worked on a project that put a geographic information system in Winn-Dixie stores back in the late 90s, where we actually could see sensors for refrigeration units on a map over the web in a Java 1.9 applet or something like that, way back then. And so I started off in that world. Fast forward a few years, I got hijacked onto a team at Autodesk that was kicking off a digital cities effort. That was about 15 years ago, and really got me deeply involved in kind of the dawn of the digital twin concept in the architecture engineering world. And we can talk a bit more about that as we have Q&A. I ended up at Esri for the last 7 years before I joined Rendered, the company I'm at now. And I was responsible for kind of bringing together the AEC world and then the geospatial world to try to build complicated systems of systems that could eventually solve real-world problems and things that we call digital twins. So, and now the area that I'm in is actually going to be hugely dependent upon digital twins, because digital twins are what are used to generate synthetic data to train AI. So I've got a quite circular experience in this area.
So we have a really great interdisciplinary group of panelists here, which feels very relevant because digital twins is a topic that is in many ways very interdisciplinary. It requires kind of a broad range of ways of thinking about space and technology and data. I know we have such a wide range of topics we're talking about today, so kind of to level set for everyone here, what are digital twins? Let's start with that.
I've got the mic. Okay, so digital twin for me is, like I said, it's a complex system of systems that needs to be deployed to solve a particular problem. I'm not the kind of person who believes that one company or one organization or one government will ever have a single digital twin that represents everything that they do. If you look at a digital twin as an enterprise system, it requires information in, you feed out reports, people have to interact with it. It needs to solve a specific problem. And what I've seen in the kind of the evolution of my career is digital twins often start out as just visualization, often for communication purposes. Then once people feel confident about them, they start moving into kind of a collaboration sphere. Then people start analyzing them, and then people start trying to get to kind of predictive analytics with them. And so a digital twin can be of anything from an airplane turbine or a power plant turbine, different things, to a utility system, to, like Karthik mentioned, NVIDIA is working on a digital twin of the planet.
Yeah, so this is it can be a very complicated thing to respond to it, but I think we can probably agree that it's a virtual digital representation of a physical system. It gets difficult, especially for us as a company that's building a digital twin software tool, to differentiate ourselves from the status quo, because the people on the ground that might use this type of technology, at least many of them, say, I've been doing digital twins from our entire career. Since we had a computer, we represented physical systems with models and models that you could simulate to assist us in design, development, operation of that system. We like to impose an additional requirement on something before it's called a digital twin, which is it provides a unique level of fidelity, and it can be utilized, or it itself can utilize information from the physical system to inform how that digital twin is behaving. So something that's more interoperable, higher fidelity than the status quo.
Yeah, wow, those are fantastic definitions. I think what I would add is, in the same way data science is a little bit of a rebranding of like statistics and machine learning and really old disciplines and kind of packaging it in this new framework, I think digital twins does the same thing for a lot of the simulation and modeling and kind of 3D CAD stuff that has been going on for decades. And so I think I agree exactly. It's just a digital representation of stuff in the physical world, and it lets you interact with that digital stuff more easily.
Thank you. So it sounds like there are a couple different components that are key to it. So there's the physical objects or the physical entities that we're trying to represent. There's some form of ways of collecting data about those systems in a live way, or maybe synthesizing like synthetic data for them. There's a way of representing that data virtually, and then of course there's all the systems underlying that to make it very interoperable and real-time updating. What are kind of some other components of it, or other pieces that are maybe you see key to that, to like a functioning digital twin system?
Okay. Other components. I'll go back to what I said in the first place. So one, I really do like the fidelity concept. In the same vein that I think that an organization or a government has many different digital twins, there are many of those twins have different fidelities. One of my former bosses used to point to folks who wanted to build a digital twin of the future at hyper-realism, at a state of hyper-realism for cities. He'd point to an empty table and say, well, most of your digital twin technology is based upon collecting reality capture data, but you might as well scan this table because the city that you want to build this twin of doesn't exist yet. So there are different different phases at which you use enterprise and digital technologies to solve problems. And for me, it's the pragmatic side of it is the twin needs to solve real problems. And we're here to talk about sustainability. Digital twins solve a tremendous amount of sustainability problems. For one, they offer the opportunity to catch problems and catch future issues much earlier in the life of something before it goes into play, before it is changed. And the earlier you can catch changes to systems, the cheaper that change is. There are many other aspects for how digital twins can impact sustainability. I'm sure we'll get into that.
So for us, I can say for the way that we see digital twins and the applications that we're trying to support, we think that the digital twin should have a simulation capability. It should include a full scope simulation capability that can synthesize everything that eventually, as it becomes a physical system, or as you gather data from that physical system, it can kind of fill in the gaps. So I think a physics-based simulation capability is a component of it for us. And I'm not very familiar with other industries, and I think you guys are more so. So I'm curious. The impression that I've gotten from just learning about how it's seen in, for example, manufacturing, is that it's primarily a way of a system that can consume, say, for example, IoT data, like the fridges that you were talking about, and display it and provide some higher level analytics to the user in real time. Whereas in our application, it's a lot of physics-based simulation and then the ability to include that physical data as it becomes available.
Yeah, I agree with that. I think simulation is a big component of it, and it's one of the big advantages of digital twins. I think in addition to simulation and fidelity, there's also this idea of like hierarchical representation. So you can think about all these complex systems out there, like the planet, right? And you break that down. What is a planet? Well, a planet has water and land and all these different components, and you want to model each of those at the right fidelity to make useful predictions at at each spatial scale. And so I think inherent in this idea of digital twins, this is idea of like hierarchical representation and different levels of fidelity at each level of the hierarchy.
Yeah, I think that ontology of representation is really interesting, and to your point, Chris, like they're different applications, and so that hierarchy might look different based on the industry-specific context or the kind of end result that's wanted. As we look towards sustainability, what are some of those applications that you're seeing, either in terms of simulation or other kind of, on the IoT side, for instance, being able to gather all of that data and maybe see inefficiencies and spaces for optimization? Where are you seeing digital twins kind of intersecting with the idea of sustainability?
Well, from a space perspective, it's utilizing the massive amount of data that we are collecting now. Not us, we're providing tools for that industry, but they're deploying, these massive constellations of assets, taking all these discrete measurements. The trends are away from monolithic spacecraft, like the pictures you might see from a weather satellite of the entire, one half of the Earth in an image that they take in IR and in the visible spectrum, and those are measurements of Earth, right? But now they're flying 1,000 satellites that have all these simpler, lower fidelity point measurements. So I think digital twins can be a powerful way to, create a framework for ingesting all of those disparate types of information from disparate data sources and locations, and creating real, actionable conclusions from them about climate change, about the environment.
Sure. I think around sustainability, there are two specific use cases that I'll share. So, we're a electric motor company. We do retrofits for HVAC systems, and HVAC systems like rooftop units, like on this building, are probably 15 or 20 years old. They break a lot, but our entire fleet of retrofit motors in the real world, the chance of any one of them failing on any given day is actually quite low. So if our goal is to build like a machine learning model to predict when these things will fail, like we actually don't have sufficient training data to really do that. And so that's where a digital twin is super useful, because combined with the simulation capacity, you can actually simulate all of these rare events and build a training data set to actually catch them in real time as they happen. So that's one example. Another one is refrigerants. So a lot of these AC systems use refrigerant gases that are they're very powerful greenhouse gases, more than CO2, more than methane. They trap a lot of heat. And similarly, refrigerant leaks are pretty rare. And so we can use digital twins as a way to kind of build up a realistic data set of what those leaks look like. When you're measuring, the expansion valve of a AC compressor or something like that. And so it's a way to augment kind of the real world data and unlock a bunch of new use cases.
I didn't know you guys were going to be selling synthetic data for me, but that's exactly what you guys are talking about. So digital twins have tremendous impact upon human sustainability in a variety of ways. Water utilities, for example, the last panel, one of the panelists mentioned predictive maintenance, and water utilities there are 20,000 water utilities in the U.S. There's about a water main break a day somewhere in the U.S. And so in terms of failure, they're kind of rare, but they're kind of not. And so water utilities, the ability to put that utility into a digital representation that actually has information about the age and construction of assets, when they were last maintained, what other assets are being, what projects are being conducted around those assets, has a tremendous opportunity to be able to be applied to coordinated maintenance, which offers tremendous savings, and to be able to predict failures, but also to be able to do things like implement preventative maintenance plans. And the city of LA, for example, I'm sure that they are all in on something that I'm not sure if they call it a digital twin, but I guarantee you they maintain their water utility in a system that's probably part GIS, part CAD, and BIM data, specifically to try to do more with less. That's one way. I love that Robbie pulled it to space systems. One interesting thing about spaceborne detection sensor systems is it is much cheaper than flying drones or airplanes to capture information from space than it is, and more sustainable than it is to do it from lower altitude systems. And we know that spaceborne sensors are going to get better and better over time, more accurate, higher frequency. But even then, we participated in a government, we bid on a government project not too long ago in which the US Army said it takes them 50 million individual pieces of data to train an AI to be 60 to 70% performant, accurate. And 60 to 70% is not what you want when you sit in the passenger seat in an autonomous vehicle, for example. And you definitely don't want that when you're working on weapon systems or other life-saving systems. And so if you think about that 50 million pieces of data, if you can use a digital twin of a sensor simulation to generate rare events and edge cases, then what you can actually do is potentially reduce the amount of real sensor data collection required by first kind of priming the pump of the AI with simulated data coming out of a digital twin. So digital twins have a tremendous opportunity to help us in all kinds of ways. If you can bear with me, I'll give you one more example. I've spent a lot of time in Germany. I don't want to paint too broad, but in one thing I've always found about most of the German teams I've worked with is they really prize precision, execution, perfection in a way. And yet in the German manufacturing industry, where they've differentiated by trying to be the best, what we've heard is that in many sectors of it, to get data to train AI for defect detection, they have to manufacture bad parts. And if you can imagine German engineers intentionally manufacturing bad parts, that's not something they like to do. But if they could simulate those bad parts and then train detection systems on those, then not only does it get you over the angst that a German may have in building bad parts, but it also prevents you from actually manufacturing stuff you're going to throw away. So digital twins actually have a tremendous opportunity to impact a wide variety of sustainability applications for all of us.
Awesome. I think you lead us right into our next question, Chris, which is as we think about the data that's required to sustain these systems, obviously there's like on-the-ground sensor data and then the ability to simulate data based on those sensors. But Robbie, you started talking a bit about kind of that top-down level of data, and AILA is doing this Open Innovation Challenge with LA County where we're looking at pest detection in trees. And one of the challenges that the participants had to figure out is we want to be able to use publicly available data for this challenge because it's LA County. And publicly available data, the level of fidelity that's available isn't always the best to be able to do something like detect individual trees. So there's kind of these fidelity concerns, there's access concerns over data in terms of do the groups that need a certain level of fidelity of data have access to that data? What are some of the other challenges you're noting around use of data, access to data as it relates to digital twin systems?
I mean, for the thing that it made me immediately think of is very different from the example of finding data for the county finding data to drive this project, but it's definitely the biggest issue that we experience regarding data for our digital twins, and it's the government, and the way that they handle data, particularly the DoD. They fund our R&D to build a digital twin platform for spacecraft, and a lot of the motivation for our digital twins is providing continuity across the life cycle of a system. So not necessarily differentiating a traditional engineering simulation tool from a digital twin platform, but providing a capability that can naturally kind of transition throughout the life cycle. But these complicated systems, and I'm sure it's no different in the commercial sector, they go through many hands as they move through the life cycle. You might have a vendor that's building the computer, a different vendor that's building your battery system, another one that's writing the flight software, and they don't want to share their data. They don't even want to share the model parameters that might drive a simulation capability, let alone the software itself or their test data. So there's a lot of work that needs to be done in a maybe standardization or infrastructure perspective, so that they can share information that's necessary and have really granular control over sharing. So to encourage people to maybe provide input that can inform the outputs of our simulations or our digital twins, but not expose all of the data they've put in to kind of train that thing or to inform what it's doing. That's how we're approaching the problem, but in all applications there's potentially some interfaces, administrative controls that can help streamline the process and facilitate data sharing.
Go ahead.
Okay. Yeah, I agree with all that. I think data interoperability and getting all the right data in the right place is one of the biggest challenges of using digital twins. It's similar to a lot of the problems that enterprises face managing data and warehousing data broadly. I think the other thing I want to point out is the tool chain or the stack for digital twins is still kind of in active development. All the cloud providers, Azure, Amazon, Google, have digital twins solutions or digital twins building blocks, but they're still under active development, and I think there's no like clear winner in terms of which stack is like the best stack to do digital twins. So you're kind of on your own, doing a bunch of experiments, trying to figure out how to actually implement these systems in a way that work for your particular use case. And I think that's going to improve, I think, over the next decade or so.
Yeah, actually, I think you're right. You're exactly right. If you go across domains, even the stacks that are evolving are very different. There are folks, you mentioned a couple, Microsoft, who I think is one of the sponsors of this event, is they've come out with a digital twin definition language. If you look at it, it's a fairly vague, high-level ontology definition tool. I get the utility of it, but it's hard to see somebody capturing an entire BIM model of an airport in DTDL, for example. There is a long way to go, but I do think the emphasis needs to be more on interoperability and integration than on kind of singular definition. And then something else that we need to keep in mind about data is especially at an AI conference, is that AI is extremely context sensitive. And so it may be possible to geospatial data where digital twins that are kind of vague and that can loosely model a water utility, for example, but the water utility for New York City is very different than the water utility for LA. And sorry, I use water utilities because I used to work for a utility provider. And everybody understands the importance of them. But so it's standards, interoperability, integration, but also remembering that local and problem context is super important, especially if you start talking about technologies like AI.
As we're looking ahead to the idea of like today's panel and accelerating sustainability, it seems like interoperability and being able to think about how we preserve context and how we enable more flow of information is important for not just kind of local level sustainability in terms of upkeep and maintenance, but also those broader scale initiatives and sharing of data. What are some of the unlocks you think that are important for making that happen? Is it just about finding that standard for sharing of data that preserves some amount of context? Is it about what do you see as kind of those unlocks they'll move us toward more of acceleration in our journey?
So specifically around interoperability and kind of like facilitating that?
Right.
I mean, standards concern me, but I think it's because I come from an industry with a lot of standards, traditionally have slowed down innovation. When you need to create a new one, it takes a very long time. This came up during the last panel too. I think just as more organizations move into it, and basically they develop, at least within each industry, a better common understanding of what the digital twin is, because it's still a question that each kind of user industry or type of user is figuring out for themselves where it delivers value, will naturally mature their expectations and naturally lead to some level of standardization. But I think, and that's happening, in the space industry. The Space Force just gave like a startup like $300 million to build a database. Essentially, we're still not really sure what it does, but it's a cloud-based repository for their data, so they can support different classification levels and interface with a lot of things. So that kind of infrastructure development, I think, is necessary to support things like digital twins, and it'll naturally grow as more companies are getting value out of their digital twin technology.
Sure. So I definitely, one of the things that I've observed over the last 20 or so years of my career is that stuff that starts out looking kind of generic, like a database or like an integration pattern, generally tends to differentiate substantially as time goes on and people find the value for it. So what is likely to happen is there isn't one digital twin to rule them all, or one digital twin platform. There are going to be hundreds of them, and they will adapt to kind of specific areas where there's high value in having digital twin applications across kind of human endeavor. I do think that one of the drivers I've seen in the kind of geospatial industry, or the intersection of geospatial and AEC, is actually the government and military. Both GSA is the largest, the Government Services Administration, they're the largest maintainer, facility manager of buildings in the US. And they drive a lot of push towards standards and interoperability. And then the Army Geospatial Center is another example of a group that I've worked with who at one point about 10 years ago, faced with kind of a preponderance of emerging standards, finally said, look, this is the bucket of standards we're going to shoot for, and you can play nice in that space unless you find a gap, and then we'll consider something else. So I think economics and also government adoption become drivers that end up being problem solvers and cause government, industry, academia to work together more. And I've seen that happen in a couple different parts of the industry.
Yeah, I agree with all of that. I think that maybe a useful analogy here is to look at web and web development. And you started out with HTML and coding raw HTML. And as people built websites for different purposes, these tools and tool chains became more customized and kind of. But at the end of the day, what ended up happening is you factor out common pieces that work for all these different use cases, something like a REST API, right? And so I think that's kind of the trend I think we'll see with digital twins is you're going to see this exploration phase where you start looking at all the different use cases for digital twins. And then eventually people will figure out like what's common amongst all those use cases and build reasonable building blocks for the rest of the community to kind of take and run. And so I think that is kind of how this space will evolve.
Construction and real estate. What are some of those industries you think that are really driving that push that might have their own kind of needs that might at some point start to intersect?
Okay, I'll take it first. I understand that the whole digital twin, I believe the whole digital twin concept started off in the space industry, actually, I think at JPL. I just read that recently. I had actually originally understood that it started off in the manufacturing industry. Back to the sustainability question, it was interesting to hear the aerospace group talk about carbon impact. It's been shown repeatedly that 40% of human carbon impact comes from buildings. And that's the construction of them, that's the operation of them, that's us living every day and having the lights on even when it's nice and sunny outside, right? So I have seen personally and helped participate in the evolution of a digital twins concept and part of the industry and technologies, specifically to help drive better coordination, collaboration across kind of the planning and design and engineering communities, so that they could actually start out building processes sustainably and then drive more information into the operational phase so that you could operate buildings more sustainably. So for me, that's been a huge driver, and I would definitely say defense, but even government in general, but like the defense community, the US Navy, for example, is very concerned about coastal seawater incursion in places like Norfolk, because they've got a bunch of facilities there, and they're really worried about having to maintain them in times when they need to defend the country or protect wildlife or do other things. And so I actually see government as a tremendous driver of digital twin technologies because of some of the kind of collective needs that we have around the country.
Yeah, so Chris took my answer about buildings, but I think there's another interesting use case around agriculture and looking at crop models and figuring out how many growing degree days go into a particular crop to get a particular yield, and building twins of those systems using geospatial data, using climate data, kind of pulling all these different data sources together. Plants are pretty complicated. And these crop models are also pretty complicated. And so it's another, I think, very useful application of a digital twin that I've seen. So I want to add that one.
Yeah, I agree with both those examples, and your word about the government helps me give a broader answer, because I've been exposed to it, through we're just seeing a constant flow of research opportunities come up, a new batch of SBIRs, Small Business Innovation Research grant opportunities for the DoD, just released a couple days ago, and I think there were probably 10 that were something related probably to digital twins and a lot of twins. So yeah, they're an entity that has a lot of complicated assets and limited labor, and they want to do things faster and more efficiently. So I think government is a great example of an ideal customer for this type of technology.
So I think for a number of these use cases, we're thinking about being able to model or have data around environmental data, around entities, buildings, machines, things that exist within a space. How are you thinking about human data around digital twins as they intersect with these systems? Or what are some of the challenges around that?
So there's a human element to a lot of the systems, including like the systems that we're creating digital twins of. So a human in the loop capability is essential, and so we need to be able to simulate their logic. So we do that in the platform. We simulate the operational logic that's planned for a space mission or for a constellation, and then have the ability to kind of exchange ownership of that control with an actual human or humans in the loop, collaboratively operating. So, for example, to train operators of these systems.
Yeah, I think it's useful to have a model of how humans interact with any system, and to capture that digitally. So in buildings and building energy and HVAC in particular, typically the person programming a thermostat is a person. And so we need to understand what are all the different ways they can mess that up, and how does that kind of lead to, what are the downstream effects? What does the data look like if they do mess it up? And how can we catch or prevent or build in guardrails to help human users of the system going forward?
Yeah, so I'll take a little bit different take on this particular question. So actually, I just got sent yesterday a pretty interesting study that was funded by DARPA. And it's all about simulating human interaction for purposes of building up these complicated knowledge graphs of information to track crime. And that's actually something that that our company poked around a little bit with. We worked with a group called Brightide that does a different type of hackathon for conservation purposes, and we were basically joining them to look at how complicated it is for an AI to scrape data, to use data scraped off of social media to detect wildlife traffickers. And it was one of my hypotheses that we likely could end up scraping the kind of data that could, if we could then randomize it, anonymize it, generate synthetic social media data, we could likely build up enough data to train AI to detect wildlife crime. And some of that work is being done by folks like this Professor Meredith Gore at the University of Maryland, and a lot of other smart folks out there. But there's a whole group of folks that are actually working on something called citizen twins, and these are essentially digital twins of humans that are built to simulate different types of interaction, just like you guys are talking about in kind of the manufacturing sense, but it touches many other different aspects of society, resource consumption, crime, and if you think about things like sex crime, wildlife crime, arms trafficking, drug crime, many of the people who perpetrate those actually do the same things. They share cryptic social media messages. They are on the same types of social media. They use the same types of electronic transfers. And so if you can crack the problem in one area with the simulation or by use of a digital twin of a set of human interactions, then you have some chance of cracking it in other areas. So there's a lot of work going on right there right now. I first heard about that in some DARPA projects about 10 years ago, I think it was, and I was really fascinated to see that it's still going, and a group has shown some success with it. So I expect that to apply to all kinds of other aspects, including kind of conservation, sustainability.
Awesome. Yeah, I think that points to a really interesting potentially use case in the future as we see how to model behavior, see where we can maybe encourage more sustainable behavior at a human level. I want to open it up to questions in a sec, but just before we do that, what is most exciting to you as you look forward in this space in the near future?
For me, it's at least in our industry, it's actually seeing the impact. There's a lot of infrastructure development, the things that I mentioned, kind of developing, the basics required to support digital twins, throughout the life cycle of a system and a constellation. I'm excited to see it actually have an impact. There's so much exciting development in the space domain, Everyone hears about it in the news. It's very kind of sexy these days. And so there are a lot of companies pumping out satellites and building new rockets. And so I think it's a perfect kind of at-scale, complicated system of systems problem that's perfect for digital twins. So I'm excited to see technology like ours getting into practice and starting to inform how these systems are built and operated and how the data from them is utilized. So.
Yeah, so as a practitioner of AI, I spend a lot of my time munging, cleaning, working with data, probably far too much time. And so I think what I'm optimistic about with digital twins is, we talked a lot about fidelity and interoperability and modeling how data interacts with each other. And so I think digital twins is a framework to pull us into a happier place around data and data management, and will really drive the industry to have cleaner data overall, which makes me very, very happy as an AI practitioner.
Yeah, so I bet many of you wouldn't believe me if I told you that back 15 years ago when I got hijacked onto the Digital Cities team at Autodesk, I actually had some other colleagues come to me from other parts of my career and tell me that I was going to waste my career if I stuck with this Digital Cities thing. Not the first or last time probably that I'll have been told that. I really love helping people solve real problems with technologies and workflows that they never expected would actually help them solve a problem. And this area that I'm in now, which is application of digital twins to generating synthetic data, when I talk to folks about it, the first thing they say is, what are you doing? And then they say, well, that sounds really esoteric. And then they say, oh, but I have all these data problems. And so I can see that this is an area that's going to really open up tremendous opportunity for folks to not have to munge as much data as they're munging on a daily basis, and instead to be able to design data using digital twins of the scenarios they want so that they can get to value faster with AI and actually get to real value for humans faster with technology in general. So that's what floats my boat.
Thank you. So do we have some questions from online?
Yes.
Okay.
So are any of the panelists investigating causal inference?
No.
Oh, well, actually, great question. So one of the applications of, so go back to what we said about edge cases and rare events and things like that, and how hard they can be to find in real data in order to train AI. So actually, one of the potential applications of synthetic data is actually to use synthetic data to actually create designed data sets to then train AI and actually observe how the AI training performance or effectiveness is influenced by introduced changes in training data sets. We're at Rendered, we're actually implementing a new set of features specifically so that users can compare real data sets against different synthetic data sets so that they can actually make changes to make AI a bit more understandable. There's this whole, is it explainable AI or understandable AI? There's a catchphrase, but I can never remember it. But there's a whole desire for folks to make AI much more explainable to real humans, and we do see synthetic data as one possible way to do that.
Okay.
All right, we have a question from the virtual audience. Are there currently digital twin systems to help calculate total carbon removal? Is it just too complicated at this point? Obviously, DAC groups like Climeworks can estimate based on their own system, but can it be used for agnostic, human-intervened carbon removal? So natural plus hybrid plus engineered. Who wants to take a stab at that?
I wouldn't know.
Well, it sounds like, if you have a digital twin of the Earth, you could model a lot of these physical processes around, carbon cycling and climate in general, climate modeling. So I think the answer is theoretically yes, and I think that's a fantastic use case for digital twins because that is a tough problem to model. And I think a lot of the project finance around carbon removal is like, how do you how do you actually compute an ROI for something that's so uncertain? And so I think if digital twins can reduce uncertainty for carbon removal, then that's a win in and of itself.
Awesome. I think we have a couple questions back there. Sorry, one second.
Hi. So digital twins are fundamental to the spatial web or Web 3.0. From your presentations, it sounds like you're doing a lot of keyboard work. Have any of you experienced more intuitive user interfaces so this could be opened up to the broader public, or is it really fundamentally keyboard based?
Our platform has one of the main things that we market to our potential users is that it doesn't look like traditional engineering software. I mentioned earlier we use, we build our front end off of React, and we focus a lot on building an intuitive user interface. We have the advantage as a domain-specific tool, like meaning we're not a tool for an industry. This version of our, this implementation of our core technology is for spacecraft developers. So maybe not to the general public, but to a space systems engineer, we have a very intuitive, straightforward workflow that looks like a modern, web application. And then all the analytics are also very engaging, at least for me, and intuitive. 3D playback of the system, visualization of the power flows through the system, the temperatures, all that kind of stuff, so making it more intuitive.
Yeah, thanks for the question. So personally, I don't use any other interface besides a keyboard and monitor, but I think, if I want to speculate a bit here, the idea of an avatar that you control in a virtual world is pretty much like a digital twin of you, your body, yourself. And I've seen some really interesting technology to kind of bridge that gap. So there's a company called Control Labs that was just recently purchased by Facebook, which makes essentially like a bracelet that measures the EMG of your muscles. And then translates that into the control of an avatar. So, I can make a gesture, and then my avatar in the digital world will make the same gesture. What's really kind of cool about it is it can measure sub-threshold EMG. So what that means is when you just think about moving your arm, it'll actually move your avatar in the real world. And so, that's kind of a niche application of a digital twin, but I think it's relevant to this idea of like other ways of, or more intuitive ways of interacting with virtual worlds.
Yeah, so I tend to be more of a lowest common denominator kind of guy. So I think that on one hand, what Robbie said, where they're moving from desktop design tools into web interfaces is very similar to what the company that I'm at now is doing. But then, on the other hand, what I have seen, so a keyboard is going to be part of it for a long time. On the other hand, what I have seen is this is the most likely more intuitive interface that a lot of things are going to. Back in 2018, I was part of a team where we put the entirety of both George Bush International Airport and then Nashville, all of their BIM data, along with 260 terabytes of Esri GIS data, were all available to be streamed to my mobile phone at a conference where I could click on any asset out of the millions in one of those airports and actually see basically see the part numbers, see the manufacturer. And then what they're doing now is hooking those types of things up to live IoT sensors and making them more of what we're now calling digital twins, where they're live connected. I think this is the most likely intuitive interface. I'm not a huge fan of VR because one, it's not really great for vision disabled people, and about 11% of us can't see color completely. And then there are a lot of folks that have other impairments. And then VR, while hyped pretty tremendously as intuitive, I said earlier to somebody that women have about 5 times the rate of nausea in VR experiences as men. So I find those parts of the industry to be not really thinking about all of humanity when they're proposing intuitive experiences. It's intuitive for a few, not for everybody. So I think phones and keyboards are here to stay for a while.
All right, I think one more question.
perfect timing. Segue. So pre-manufacturing, digital twinning was being used by the entertainment industry in the 1980s. Obviously, that's why films cost us gazillion dollars to make. It's not just the actors. Digital humans, digital actors, AR, VR, especially in LA, because of the billions of dollars that have been thrown into this industry since including the 80s. So we segued from analog into digital, digital scanning and 3D mapping of environments. So if you're shooting a film around the world, you're able to produce at the studio the actual digital, the real time, real life digital set, digital environment, but it's based on reality. And the same way with the digital humans that are being created. There's a company here in LA that's called Digital Domain, which are famous for things like Titanic film. And a lot of the Scientific Academy Awards have been won the last couple decades for artificial environments, digital scanning, digital twinning, things like that. But the reason I mention it is because since we're talking about sustainability today, my question is, when we look at digital twinning, if you take it to the next generation, the next step of use, then you get into digital mimicry. So for instance, in the case of films, we already have digital actors, digital humans, where we've taken a 3D scan or using motion capture, generating an amazing amount of data, being able to source that, being able to comb through it, being able to find the details in it. But then you get into mimicry of it. So if we were scanning another planet or scanning or mapping the sun, do we get to the point where through digital mimicry, where we actually have enough data that we can simulate the energy that the sun is creating, even though it's organic? There is a point when the data capture that we're doing, it's organic too. And can we actually train it to be a mimic of the sun, where we're actually producing the energy we need through artificial means?
Well, I think as a tool that helps us understand complicated systems and simulate complicated systems, I think it naturally contributes to our ability to, create analogs, I guess, to those things. I don't see us creating a sun, but certainly, maybe understanding natural systems through digital engineering is not an area that I work in at all. But they follow the same physics, and so I think if you have physics-based digital twin capabilities that can generate data that informs AI, maybe AI can help you design analogs for naturally occurring systems. So yes.
Yeah, I like the concept of digital memory. I think we do that a lot, actually. A lot of the sensor data that we capture to build these models of the physical world, you can then go back and replay them. And in fact, that's one of the ways we generate synthetic data, is you take something that happened historically in the real world, replay the data, and add some noise or some other physical simulated process to that in order to generate like something that's novel or a little bit different, or something that's within the realm of possibility, but that has never been seen before. So it's digital memory, but it's kind of like augmented digital memory to produce like a realistic simulation.
Yeah, I mean the sun. I'll echo, like there's scale problems, right? So that's not to mention OSHA problems there, but I very much do like the idea that one of the things that we're doing with AI is we're learning how to build up inference in different ways from traditional kind of classical modeling patterns. And we have a lot of problems to solve around things like, in 2020, there was about, I think it was 100 terabytes of data being collected about the planet a day from Earth observation satellites. Fast forward, by the end of this century, end of this decade, there's supposed to be 5,000 satellites up. Back then, there were only about 200. So what are we going to do with all that data? How are we going to use it? We need to have better digital systems for just-in-time analyzing, then storing information about all that data so that we don't need it all, but we can kind of unpack it, explore it, and then make future inference and decisions. So I think there's a lot of opportunity ahead of us, and I don't even think we can see what the full breadth of possibility is.
Well, I think that's an optimistic way to conclude our panel. Thank you for being with us today. Thank you all for sharing your thoughts. To Karthik as well, who we lost to the digital version of him. But thank you, Chris, Robbie, Nikhil, for being with us today. I know there's so much more to discuss in this area, so if you snag any of the speakers, maybe you can ask them questions. But thank you all.